Perfect. Well, thank you very much. It's my pleasure to be here this morning on a very cold but clear day. You always know that if the sun is out, it's going to be very, very cold. So I'm glad to be inside actually and talking with you all and talking about digital golems and such like. So I'm just going to share my screen here for a second. There we go. You would think after so many years doing Zoom that I would be capable of making things work on the first try. But I think we're good. Y'all can see that. Fantastic. Yeah, so teaching is definitely a big theme of what I'm would like to speak with you today because one of the nice things about the weirdo in my department, being a Romanist hiding in a Canadian history department, is that nobody really knows what I do. And so I propose courses around things that I want to explore, and people let me teach them because they trust that I know what I'm talking about. And more often than not, that's not the case. I teach to explore, to figure things out, and by the end of a course, I might have a sense of what I'm talking about. But by doing this, it becomes a really fun exploration with my students if I can, get them to trust me that we're going to end up somewhere interesting. So this past year, I've been teaching a senior undergraduate seminar in digital history on exploring what AI means, what it implies, what the ethics of it, the safety issues, the dangers, the should we even do anything at all? And that is absolutely on the menu for my students, that the whole premise of the course might actually be undermined by what we do. And so bringing history students um, to do this kind of work, you know, the history student is a very small c conservative in the sense that they come to history class with a sense of what history is supposed to be about and how we do it and the proper way to do it. And sometimes the digital things that I try out with them can be a very hard sell. And so I need a really strong metaphor to capture people right off the bat. And the golem is such an amazing and interesting figure. And I'm not a scholar of Jewish mysticism, and I'm not doing justice to the cultural significance of the golem. But you know, the idea of the golem as an unfinished human or an unsophisticated human, the idea that the right word of power, one of the names of God, could animate the thing and make it useful, really seems to resonate right now. And of course, the story of the famous Golem of Prague in the 16th century, Rabbi Lowell, who creates the golem to protect the community, but then has to destroy it because it starts pursuing its own terrible desires. That's also uppermost in my mind these days when we talk about AI, and especially when if you listen to the hype of AI and its major backers and tub thumpers who tell us that the end goal is artificial general intelligence. Um, if we think of AI as simply a technology where neural networks are used uh, on linguistic data, that's very much a digital golem powered by the words in its head. But, the power of those words, it can go off the rails in interesting ways. Bad things can happen. And so I want to make a distinction between AI and AGI, where AI is a model, AI is a technology, but AGI is a political, religious, millenarian belief, an end times goal. And especially when you look at who some of the major proponents of that are and where they are managing to achieve political power at the moment, that aspect of all of this becomes very frightening. So this isn't a political talk, though. I want to look more at the technology first. I want to understand what it's doing because the hype is so strong. It's really hard to have sensible conversations about it. And it's very hard to teach about it because students come exposed to nothing but the hype, right? So I want to outline for you today how my digital archaeology work using agent-based models, which is also a kind of population of digital golems, leads to this current work exploring neural network models for exploring archaeological data, historical data, and how it guides the way I do it. And I'm very much intrigued by the idea that Ted Underwood has, amongst others, has mooted that AI are not models of language, but rather models of culture. Because if they're models of culture, then digital archaeology has to be at the forefront here, um, lest the digital golems get out of control. So, with all that preamble out of the way, let's get cracking. Star Trek Lower Decks, anyone? It's a great show. That's an evil computer that's taken over, but not the slide I want to show. So I come to these digital golems. Firstly, if we turn the clock back to my PhD work, which was on the Roman construction industry, I started with social networks. So not neural networks, but just rather seeing social networks. And in that early work, I regarded each one of these kinds of stamped bricks from the 1st to 3rd century in the Tiber Valley as a kind of point in a multidimensional space, right? So each stamp on a Roman brick, not every brick was stamped, only a certain number per batch, but a stamp has information about the workshop, the people who made the brick, the estate on which the workshop was a part, the ownership of the estate, the year of manufacture, and maybe even information about the warehouse in Rome to which the bricks were destined. The clay of the brick has inclusions that tell us something about the geology of the location of the workshop, and so location. And so you can start connecting things up. You can see individuals moving from one estate to another estate. You can see different families taking over estates. You can see estates merging. You can see them breaking apart. So all of this can be stitched together into a really detailed network of actual past individuals whose names we sometimes even know. And network analysis is not uncommon now in archaeology, but at the time it wasn't an easy thing to do or visualize. And the hardest part of it was dealing with the time dimension, dealing with the temporal dimension, right? And there's no really good way of exploring or analyzing network evolution over time. And what we tend to do is a shortcut where we take a snapshot at time 1 and a snapshot at time 2, and then we tell a really nice just so story to get us from 1 to 2, right? We use our storytelling to bridge the gap. And so that was enough to get me through the PhD, but as a postdoctoral researcher, I wanted to really address that problem of telling the story between time 1 and time 2. And this is where my digital golems first came to be, right? We can tell lots of interesting stories. And how do we compete? How do we tell or judge between competing stories? Well, this is what agent modeling is for, because I can give such a model the starting point, iterate through all the possible combinations parameter, exploring and asking, well, which one leads to something similar to my next snapshot? And this is really about addressing the problem of equifinality, the idea that multiple paths could account for the things that we see archaeologically. But knowing the start and finish that I'm interested in, and knowing the right combinations of parameters and circumstances that get from one to the other, can be a really powerful way to visualize the landscape of all possible outcomes, and so tell a better, more plausible story, right? So we're not trying to tell the one true story. We're trying to see all of the conditions that could lead from this transformation to that transformation. So if you haven't explored agent-based models, a really fantastic place to get started is with Romanowska, Wren, and Crabtree's open access book and tutorials on ABM. A general, maybe I need to back up a moment because an agent model is an environment with many software agents active within it, each one with their own unique combination of parameters who interact with that environment and how that interacts with the rules, right? So it's like a football game. Everybody on the pitch knows the rules, but every single individual has a different combination of abilities, experience, and training. And so the interaction of the rules with that individual and with the context, with the field, with the crowd shouting, with the bad refereeing, leads to a different kind of game. So the game, the experience of the game is an emergent phenomena dependent on the individual actors. So I do that for my networks where each individual agent represents an individual known from the Stamp Brick network and their connections. Okay. So if the network is true, then the emergent interactions from that starting point have to have some necessary connection to the past. I put words in the agent's digital heads that they try to follow, given the contingencies of their own abilities intersecting with other agents in the environment. They are golems. So that was where my first experience with this idea of the digital golem. But emergence is a real, can be a real pain in the butt sometimes. The thing to remember about golems, the thing that the story of the Golem of Prague reminds us, is that they sometimes go off-piste, right? And they do things that are unnerving. At one point, I was very active on Twitter before it became even worse toxic hellhole than it is these days. And I used to make Twitter bots for humorous purposes that would engage with users around archaeological themes. They were just toys. They were powered by a replacement grammar called tracery that would recombine sentence fragments and vocabulary lists in particular ways and contexts. Some of the bots were actually useful. There was one that would retweet publications from RSS feeds. But the one that probably was the most sophisticated was the Tiny Archie, which was a kind of soap opera to skewer the worst excesses of academic fieldwork culture. And one day I posted a tweet that addressed a number of my different bots all at once. So I tagged a number of them at the same time. And this caused their autoresponders to kick in, which set off a day and a half of conversation rounds between all of the different bots. And that was entertaining to watch at first, but then got progressively more and more unnerving. And so I tweeted something to the effect that, well, maybe this was a bad idea. Maybe I shouldn't have done that. To which one bot responded, "We're all afraid that Shawn will kill us." I should have taken a screenshot, but I went in and I started killing the bots lest they take over. But it was creepy, it was unnerving, and it was just an accident of the programming, right? The Twitter bots did not actually have any real agency, but the illusion of intelligence emerged through the combination of triggers and vocabulary words with the human tendency to see agency and intention in things that have none. Right? We are subjected to a kind of pareidolia, especially when we're interacting with things that seem to react in natural text. There's a strong tendency, I think, in Western history, and maybe perhaps further afield too, where we've always had this thing where words and how they combine or recombine can be seen to have power. Sometimes we call that writing, but sometimes it's more mystical than that. And of course, there's this fantastic quote from Terry Pratchett from one of his novels from about 20 years ago, where he, for humorous intent, talking about somebody in the unseen university, whose job it is to parse all of the books that haven't been written yet. And it's obvious because books inspire other books written in the future and cite books written in the past. In that case, the contents of books as yet unwritten can be deduced from books now in existence. So Terry Pratchett predicted our modern AI 20 years before it finally emerged. But this idea of the power of combinatorial thinking, we could call it, it goes back to at least the 14th century, if not earlier. This is a potted history. I never said I was a historian. I just somebody who farts around on the internet for a living. But if we go back to the 14th century, the mystic, Spanish mystic Ramon Lull, had this thing, the Ars Magna, where he would recombine words of power to provide insight and guidance. Leibniz, in the 17th century, developed Lull's ideas into his own art of combinations. And they both had this idea that there were fundamental things in the world through which complex ideas could be expressed, and that there was a method for remixing these elements to calculate, not mathematically, but to calculate to know new concepts, new ideas. We can see this still at play in the 19th century. This device here on the 19th century is the Eureka machine by John Clark of the Clark's shoes family. He was a polymath and a tinkerer and part of that 19th century British, let's see what we can build. He was inspired by the idea of the kaleidoscope, a relatively new device at that time that, using mirrors and lenses, could display new astonishing images through a kind of automatic pattern generation. He applied what he called kaleidoscopic evolution to the inflected forms of Latin verse to devise a machine that could write around 26 million unique lines. And the point of doing this wasn't simply to generate Latin verse. Rather, he saw his machine as a way of implementing his own theories about language and inspiration, what we would now call cognitive science. And I'm following the work here of Mark Sharples of the Open University, who sees in the figure of John Clark an early theory of cognitive science, right? So he saw language and cognition as having statistical properties that could be implemented in a machine. So there's no way you could do a talk like this without touching on Claude Shannon at some point. Especially with his creation of information theory, right? So Shannon worked out for his MA thesis how Boolean logic could be represented by electrical circuits. And then in a follow-up, by looking at the noise in telephone or telegraphic communication, he worked out that one could measure the amount of damage a message could take before it became unintelligible. And he quantified this as information, and so divorced the idea of information from its meaning. Information becomes a measure of the entropy of the message. Anything you do to reduce the uncertainty reduces the entropy. And so he showed that even doing something like in a written message, introducing a space between words could reduce the entropy, right? Hence, the space was part of the information. The space is a cultural practice. You don't have to write with spaces, but we are habituated to do that to set off words. Other languages don't do that. So cultural practices could be captured in this measure of entropy, in this information, right? So this is a potted history, and I'm sure historians of communication and science and technology are rolling their eyes at me right now. But it seems to me that this brings us to a point where we have a method for the kind of combinatorial exploration that Lull and Leibniz and Clark and others sought, and we see that culture can be embedded in the language as the information, as something that can be calculated. So metaphors for understanding the brain, right, often take their cue from the dominant industrial themes of the day. Once we were all clockwork brains, once we were all steam. And at the time that Shannon is working and creating the whole nascent digital age, folks rightly wondered, well, maybe are we like computers? Are computers like us? Well, if they are, then these circuits might be more like neurons. Well, how do neurons work? And what can we learn from that? Well, by the 40s, right, the biology of the brain was still a very developing thing, but the key idea that biological neurons are wired to other neurons, and in the right circumstances, given a particular input or event, the neuron will fire. triggering another neuron to fire was basically understood, right? So the pattern of firing could be associated with some phenomenon in the world. I look at a cat, the right pattern lights up in my brain. That's the idea of a cat in my brain. The biology is way more complex than that. We know that. But in the 40s, the researchers sought to make the basic idea of work mathematically. And it did, with this simple idea of a single layer of neurons that would activate given an input and could be associated with a label of some sort, gives rise to this idea of the perceptron. And it was discovered fairly early on, mathematically again, that if you could stack layers of these neurons, if you could wire them together, if you could figure out how to wire them correctly and get the right weights and balances, you ought to be able to do some quite sophisticated pattern matching. But the problem was how, right? It's one thing to know that it should work in principle. It's quite another to actually work it out in practice. And the math just, was too complicated, couldn't be done. But nevertheless, throughout the 20th century, in the 1950s, Shannon, Minsky, a number of people came together for the famous Dartmouth seminar where they said, we're going to solve the problem of artificial intelligence in, the next 6 months. They were very ambitious. And over the 20th century, lots of different work, lots of different strategies for AI emerged, as it always seemed to be one of those problems that was just 5 years off. And the actual phrase artificial intelligence falls into bad odor periodically because of overpromising and underdelivering. And so other approaches are used. The problem with neural networks was the problem of the speed of calculation, automatically figuring out how to wire the damn things, and just how much data do we need to train on? Well, NVIDIA creating the GPU for consumer grade parallel computation so that we can simulate blood splatter in video games hits the market in the 2000s, or in the late 90s rather. Well, this solves part of the problem, solves the computational part. The idea of back propagation, the idea that you could measure the difference between the error and where you want it to be, and then use that to trickle back changes through your network automatically to get a better result. Lots of people are involved with that, but it's most famously associated now with Geoffrey Hinton and his circle of people. So that solves the second problem. And then Fei-Fei Li, working first as part of her PhD and then later as a researcher on computer vision, standard computer vision approaches, discovered that simply getting more data available would make better results. And so she, first with her team of students and then discovering that you needed more people to do it through Amazon Turk, so parceling it out to piecework workers, creates this enormous data set that we come to call ImageNet, which, when used with very nearly any algorithm, creates so much better results because there's so much more data that the system can use. Which brings us to about, the last decade or so, right? We now have the data, the algorithms, and the hardware to do it. And while this, all these other approaches to artificial intelligence have largely dropped away now. Now all of the money is in the neural network approach. In archaeology, when we're talking about AI, most of the time, we really are just talking about pattern matching in the computer vision side of things, which is now available to us on archaeological budgets, thanks to these developments. And, it's at this point where you can do it in your browser. If you expose enough labeled examples to the machine can learn what the categories look like. So this kind of neural network can recognize earthworks in LiDAR, pottery types from shards, ink on carbonized scrolls. But when you take these models and you add extra layers to them of different kinds of models. When you start fusing models together, interesting things start to happen. And this is where we're at right now, right? So this is where all of this hype is, where the chat is. And Jeremy Huggett, in his blog post, AI and His Affordances, has this really important piece exploring a framework for how we can make sense of it, drawing on Marshall McLuhan's explanatory probes for systemizing and understanding what a new tech can do. But I think we're not ready for that step yet. I think we need to have a better kind of hands-on practical experience of what these models are doing, divorced from the hype, right? So we need to build our own digital golems before we can even start talking more about these other things, right? Does that make sense? I think that makes sense, right? So I want to start with the data side to all of this, right? Generative AI, so these neural network models that are not just identifying things, but are being used to produce new text, new images, whatever, they require so much data, the entire internet. But more data isn't just quantitatively different, it's qualitatively different too, right? As Faye discovered, it requires, when we do this large scale data strip mining, turning experience, associations, and memories into data through it turns these things into data through a process of progressive forgetting. In archaeology, photos from an excavation will end up online. The team will move on. The meaning of those photos, the memories are now an archive described by the metadata that gives the who, what, when, where, why, and how. But the larger sense has been lost. The importance, the impact, the effect, the enchantment in Sarah Perry's framing, the meaning. And then when an archive is consumed at scale to train AI, all of that metadata gets stripped away too. Each cognitive layer is flattened. And so a picture of an atrocity carries the same weight as a picture of a holiday. They become juxtaposed. They are just individual data points. And then when we train a network on all of that, there's a further decontextualization through a process of decomposition and decay to pull an image and text into the same model space. You decompose the data into noise. For an image generator, the generator just reverses that process and traverses the noise, finding a path through the data to an average point associated with a given label. So here in the top left, these 6 images, where's my mouse? There we go, those guys, are created from an image generator with the prompt, an ancient Greek 5th century red figure Cantheros. Same prompt, 6 times, 6 different images. We see differences in similarities, but from an algorithmic perspective, the only difference between them is in the initial random noise from where the generator started. You look at the other 3 images, these are from 3 keywords, walking couple, or what was it? Walking city night or evening or something like that. Notice the shadows. There's no actual light source in these images. The shadows are just their literal shadows of the data where the image has learned that people sometimes have shadows, right? They're not photographs, they're ontolographs. They're images of what's going on underneath in the data set. When we notice similarities in the composition of these kinds of images from the same starting point, what we're noticing are attractors in the model's understanding that guides the path through the noise, right? So just like in an agent-based model, there are attractors in the landscape of behavior over time. These generative AI similarly have attractors in them, and we need to We need a way of mapping those. And Eric Salvaggio, a professor and artist, digital artist, argues persuasively that every generated image, every generated text is an infographic of its underlying data. It's the mean of aggregated patterns. It's not creative, but conservative. It can only generate an average of what it already knows. And across the bottom here are the results of work in my class with students where we generated 100 images of archaeology, fieldwork, excavation, and used a image similarity tool to cluster the similarity. And when you look at it, you can notice that an attractor in the model's understanding of Roman archaeology is clearly photographs of the latrine at Pompeii, the latrine at Ostia, where everybody sits on it and gurns for the camera. The positioning of the humans in every single picture. So those tourist photos of the latrine are occupying a big space in this model, it seems. So to get to that point, right, we talked about Shannon and the idea that cultural things are embedded in the information. When you're generating a model, the image data and the textual data have to be embedded into the same space, right? So it's a process of turning that information into a direction, a series of numbers where each number describes a position along some dimension. And then you have the image and the associated text as vectors in this space, right? With students, and when I talk about vectors, I say, think about latitude and longitude. We express coordinates on the Earth as a two-dimensional vector. And if you know the vector for Ottawa and the vector for Berlin, you can measure distance between those vectors in the model space, and you know something new about this world that isn't actually implicit in the vector itself. So similarly, a 2048 dimensional image vector tells you something about images, and you can measure distances and so on. This way of modeling language, where we use a neural network architecture to express the complexity of language as some kind of multidimensional vector, is extremely powerful. I've used this approach to model statements of fact about the antiquities trade, a knowledge graph, creating an embedding space of that knowledge. Once an entity is embedded, a person, a company, a museum, sorry, my cats are screaming at the door and it's really distracting. Why do academics have so many cats? Anyway, when an entity is embedded, you can start doing this kind of measurement. And so we discover new knowledge. So we did this with things known about the antiquities trade. And one of the strongest, closest relationships was this one between Leonardo Patterson and the Brooklyn Museum. And there was nothing in the model, no statement connecting Patterson to the museum, but Leonardo Patterson is an art dealer with a sordid past. So we started looking for why would it be returning this? And we actually discovered a connection where Patterson was making donations to the Brooklyn Museum of small-scale forgeries long before he ever rose to prominence. So it directed us to uncover a moment in his career where he was building his legend as an art dealer, just from the embedding space. Imagine if we expressed what we know about ancient culture in such a space, right? So this ability of neural networks to represent complex multidimensional material in a single space is something worth exploring. But we don't have models of ancient culture expressed this way. Rather, we've got models of modern culture as known from the World Wide Web. We've got these words in our digital golem's head, all that data. We don't know what these golems know, what they've been trained on, or with what emphasis. And the intelligence, such as it is, emerges as a function of the statistical properties of language of scale and averaging what occurs. But that's not how intelligence is marketed for these models. And to understand that, we look at context length, right? When you're training a neural network, at least using the approaches developed by OpenAI and Anthropic and other Western companies, you train it on fragments of text similar in length to the length of the text you'll eventually want to complete or fill in. You block out words, sentences, paragraphs, pages, and work out the error, readjust the weights and activations, and try again. And what you end up with is a model of the world, or at least the training text, that has a statistical representation of how all those words go together, given a particular starter phrase. And that starter phrase can only be so many characters or word fragments or tokens long. And that is the context window. Once you go beyond that window, the model loses the thread. So the size of the context window is really key to most of the seeming capabilities of the model. And the popular history writer Steve Johnson points to the figure of Henry Mollison in this context. Henry Mollison is famous in the history of neuroscience as a particular patient of note because, well, unfortunately, in the mid-20th century, he suffered an accident which left part of his brain damaged, and it required surgical intervention. He couldn't form new long-term memories. Everything up to the date of the surgery he knew. He could function day to day, but each new day was like that first day after the surgery. If you needed him to do something that could be done during a day, that was okay, but nothing longer. According to his doctors, it was always like starting over. That is what the context window is like for our digital golems. And it's that problem of context length that causes generative AI's massive energy and climate implications, right? It's only as useful as the model is long. So this is why conversations with AI can go off the rails so quickly. And if my math is right, going from these figures, training the Gemini model required nearly 17,000 more times the resources than the GPT-3 model. And if you remember the hype when GPT-3 came out, this was the thing that was going to be so dangerous that it could never be released. It's the context windows that are killing us. And there's something macho about that marketing too. My model is so big, you know, I'm looking at the window here, looking for people to laugh when I do that kind of thing. And okay, thank you. It's hard talking to a glass screen, right? But the thing is that my big macho model thing has been kind of rather undermined in the last week with the release of the DeepSeek models from China. Right? When a resource-constrained Chinese startup can demonstrate that the large-scale data strip mining and resource burning might not, in fact, be necessary, that is a challenge. It's not that DeepSeek won't return results about Tiananmen Square. It's not that DeepSeek is based in China. It's that DeepSeek undermines the rhetoric and shows the emperor has no clothes. And that's why there's a challenge. All of these models have these guide rails in them that won't do things. GitHub Copilot won't return code if the variable name has the phrase trans in it. The people controlling these models in the States, we can see lists of banned words and concepts emerging already. How long before those things are built directly into the model? So this is why we can't just deal with these things on an abstract level. We have to get in and start fiddling with them ourselves to see what happens. Now, this is only one part of the picture. There's another part. The neural network, the words, only become a golem when we give it a form, a body. It only becomes a golem when we corporealize it. And in this case, it happens when we merge it with a chatbot interface. So Joseph Weizenbaum, a key figure in AI in the 60s, 70s, and 80s, created a chatbot called ELIZA, powered by symbolic AI. It was a simple program that would recognize keywords from a sentence and then using various templates, return those keywords back to the user in the form of a sentence in a format deliberately chosen to represent a kind of psychotherapy technique. You remember my Twitter bots? They're very similar to this. And the story goes, apocryphally, uh, nobody actually knows who the secretary was. Did it actually happen? But anyways, the story goes that a secretary asked Weizenbaum to leave the room so that she could have a private conversation with Eliza. The story resonates because this projecting of human personality onto a computer program with a text interface is so pervasive, so common, it's now called the Eliza effect. So these AI models, these neural network models, right up till GPT-3, as long as they were completion models, where you had to give it a string of text and it would just continue the paragraph, they didn't have much take up. They were interesting, but they were little more than a curiosity. But when somebody at OpenAI welded a chatbot on top of that, that human inclination to pareidolia and parasociality captured by the Eliza effect suddenly imbues these models with intelligence. And as with image models, all of these chatbot interfaces for models, and as I alluded to with DeepSeek, they're models on top of models. The base model, the foundation model, the frontier model, whatever you call it, captures the basic language structure. Others capture how instructions are answered. Others use human reinforcement and feedback to figure out what is a sensible or appropriate looking answer, not a true answer, but something that looks good. So bullshit is actually encoded, hard encoded into all of this by people working for next to no money, being exposed to all sorts of hateful speech. So there's all sorts of human and social costs of just the training of it. And then you put a chatbot model on top of that, right? You get the Eliza effect crossed with the Incredible Hulk. The cost of training all of this is, as we've seen, largely enormous, at least the way that American companies do it. How do you recoup the money? You lean hard into that Eliza effect, and you argue that you've actually created artificial general intelligence, that any day now we will have the machine that can take care of all of our worries, right? And Timnit Gebru and their colleagues have looked into where does this idea of artificial general intelligence come from? And they found amongst its proponents a constellation of philosophical or ideological worldviews that ultimately have their roots in second wave eugenics in the 20th century. And it's so pervasive, they're able to label the different strands of it, which are mutually reinforcing, creating this bundle, right? In essence, it's a kind of millenarian end times belief. The proponents of this, not every single piece, but in general, imagine a future kind of human who happens to look a lot like them, bald white guys on the internet, living in a future where human prosperity and utopia depends on an all-knowing machine smarter than humans. If there's a chance that such a future can come to pass, then the greatest good that can be done right now is to work to bring that future into being. And if you happen to be the human who does so, well, then you'll be the most important human who ever lived. And since we're already the most important humans who've ever lived, then obviously it's going to be us, right? So this TESCREAL bundle is really pernicious and it's really dangerous. And when folks in this domain worry about alignment, or they hire somebody to look after model welfare, or they tell us that we might be causing psychological harm to the model from all of our prompting, that's a rhetorical thing meant to prep this kind of world. They don't mean the demonstrated harm already happening. They mean the chance that the God they're making won't like humans, or the harm that not bringing about this utopia might represent to the billions of future humans. Don't worry about the damage we're doing to climate through training AI. God or AI will fix it for us, right? That climate thing, that was actually like a literal headline. Don't worry about climate, AI will fix it, so we got to burn faster. Right. So how do we actually teach or explore or make this consume? How do we build an understanding, right? So I'm drawing in this set of notebooks that you're welcome to explore. I'm drawing on those early experiences with agent-based models where we try to understand what a model does, what a model means through what a model does, by sweeping through every combination of parameters, trying to understand its behavior space. So these are from my class that's currently underway. Um, and pushing back on models is emphatically not what OpenAI and others want us to do. They want us to be sublimated within them, to just accept what's given, to quake in the heroic majesty of the model that has been built. So we got to break things. And the first notebook is a completion model, the GPT-2 model, an early one, but it's small enough to live inside a Google Colab notebook. And I get the students to fine tune it on the published output of Flinders Petrie. Now, by the time we got to this notebook in class, the students had explored and been horrified by the industry that uses AI models to resurrect the dead and markets it as resurrection, right? So Project December and the simulation of the man's girlfriend trained on her emails and texts. Henrik Schoenemann uncovered a similar use of AI from an education technology company that was marketing Anne Frank as a resurrected model. So in this notebook, we call it Resurrecting Flinders Petrie, but it soon becomes apparent to the student that no such thing is happening at all. And it allows the students to observe the differences that the means of interaction makes, right? It removes that chatbot layer so the students can see that impact. And instead, it's all about completing text. They see the error, the messiness of the model before the chatbot layer happens. And because we're training with the published output of this 19th century scholar and all that that entails, we know that statistical associations between words and phrases can be used to deduce discourses within his texts using traditional, if I can say traditional, digital humanities text analysis tools. The students realize that the completion model gives them a way of sweeping the idea space contained in his public face, his public writings. And they can see that none of this is actual Petrie himself. So this gives students agency to really get to grips with how a model works, that it isn't magic, that it isn't God, that it's just whispered echoes that recombine in a particular space. And it gives them the license to break things and try things. The second notebook, we've seen some of its output earlier. This is where we take multiple images trained from the same prompt and then use Yale DH Pixplot tool to cluster the images visually so that we can see the attractor space in the models, right? So the power of the Pompeian latrine. The third model is doing the same thing again, but this time through chat with text. So we chat with a model and ask it, tell me about the burning of the Parliament in Montreal in 1849. And the model will confidently assert that that never happened, or that the British Parliament is built in a particular Gothic style. So we generate multiple responses and then do a topic model, another traditional DH text analysis tool, on that to see the landscape of discourses. And then for extra fun, in that final notebook, we can set two models into conversation with each other, much like my Twitter bots, around a particular topic. And that really illustrates to the students just how pernicious the layer of control of the voice and style of a chatbot. Basically, every conversation degenerates into tech bros cheering each other on. Yeah, that's great. Yeah, brother. Yeah. It's amazing how fast it occurs. And of course, you can topic model that too to see how it goes. So that's how I've been teaching with these tools, right? And then with the students having developed an intuition of what these models do and how they behave, we also consider Drew Brunig, scholar and industry guy, his typology of AI use cases, gods, interns, and cogs. And these are three that I've built. And the God doesn't work. I gave it all sorts of basic archaeology, and it just doesn't do the thing. And you can't sweep the parameter space of a God. The intern is meant to translate my research questions into database queries because I can't be arsed to learn how to write SQL properly. And it works to a degree, but like Henry Mollison, it loses the plot very quickly, and what it returns is actually more work to try and sift through than if I'd just done the damn thing myself. The only thing that has really worked for me so far has been this idea of cogs, of creating something that helps with one little part of my overall workflow. And in this case, it's transcribing handwritten text in documents. So this handwritten text extractor actually works quite well. I can feed it an archaeological single context recording sheet, and it can pull out the stratigraphy, the stratigraphic relationships for me, because it's just recognizing cursive letters and where they are on a page. So that actually works well. And with that kind of thing, there are ways of double checking the work. You can use it with different models. You can fold students into that work. You can do it yourself. So there's the cog approach seems to work best and seems to be safest after we've gone through all of these other elements. And so my students are currently trying to figure out what cogs are ethically and sensible given particular research questions that they want to do. So if we'd had this talk in about another 2 months, I'd be able to show you some of what they've gotten to, but right now it's work in progress. We are experimenting with fine-tuning AI models for particular tasks. And if you look in that GitHub repo, you'll see some other notebooks that are very much work in progress experiments where we're trying to fine-tune a model for particular tasks. We're trying to split the difference between interns and cogs. But when we do this, we're rather like the scientists at Jurassic Park, filling out the DNA of the dinosaurs with that of frogs. It might look like a dinosaur when you're finished, but there are some critical differences that are going to, well, let's say, disrupt your plans. The golem of Prague had to be destroyed because the words in its head were the wrong words for what its creator needed it to do. Words and their relationships en masse have weight in the world. They're capable of being activated to different ends through these neural network technologies. The notebooks I've discussed and my idea that we can understand something of the appropriate context for using AI if we sweep their parameter space is just one approach. You might think it's not a very good approach or that I've forgotten something critical, and that would be okay because maybe you've got a better approach, and that's what we need right now. But right now we can't throw our hands up in the air and just ignore it. The golems are right there. The golems are at the gate. And like how the figure of the golem is a product of a particular culture at a particular time and place, we can examine to learn something about the culture of that time and place. Our digital golems are similarly models of culture. And if we're in the business of understanding past culture, what would it be like to see those words activated? It's not enough to fine-tune such models with domain-specific data. But maybe the DeepSeek episode really demonstrates that we don't have to accept the digital golems that American techno businesses have created. Ted Underwood has made this point several times, that computer scientists have proved that humanists are right, that texts beget other texts, and so doing reproduce culture of their data. So what would it mean to train such a model from scratch, not to fine-tune it, but from first principles on archaeological data, on everything we know about a particular culture? What would it mean to have an actual Roman AI? It's worth giving it a shot, maybe, or at least thinking it through. And then we would be in a position to talk about what generative AI might mean for archaeology and history. Thank you, folks.